Good afternoon, friends. Now in this session we are trying to cover thermal properties of matter. In this chapter these are the different articles we have to study. What is heat and what is the temperature? These are the basic concepts coming across us, but we are not knowing the difference what is the heat and what is the temperature. Today we are planning to study the difference between heat and temperature. Then we will see heat is measured in the terms of calorie. Then what is the calorie we have to study. Then we will see the concept of absolute temperature. What is the absolute temperature and how we can go to the state of absolute temperature. Then we will see different temperature scales. You know, temperature is measured in degree Celsius, degree Fahrenheit or degree Kelvin. These are the three basic scales we have to study, and after that we will see how these temperatures can be converted from one scale to another scale. Means how degree Celsius will be converted into Fahrenheit, Fahrenheit into Kelvin, or degree into Kelvin. Means we have to see relationship between three temperature scales. Then we will see what is the steady temperature state and what is the variable temperature state. Then we will see what is the temperature gradient, how temperature gradient can be calculated for any thermal body. Then we are going to discuss about the most important article in the chapter, that is the law of thermal conductivity. Then we will see good conductors and bad conductors of heat with examples. Then we will discuss about the modes of transmission of heat. Means heat can be transmitted from one region of a body to another region by three modes of transmission: conduction, convection and radiations. When you heat any solid body at its one end or at its one region, then heat energy will flow from its one end to another end. This process is called as the conduction. Then we will see what is the convection. If you consider one beaker and in which quantity of water is supposed to be kept, when you heat the water at its base, then after certain time, that means those water molecules are present at the base, they will absorb heat energy from heater, and this heat, after absorption of heat energy, the molecules will move from base towards top. That means transmission of heat energy takes place from one region of a liquid to another region by the process of convection. We will see in detail. Then we will see about the process of radiations, how transmission of heat takes place by the radiation process. That means we know we are getting the heat energy from sun. Sun radiations are coming from sun on earth's surface, and we are getting the heat from sun radiations. That means we are getting the heat in the form of radiations also. These three modes of transmission of heat we have to study in detail, and then we have to solve few problems based on the law of thermal conductivity. Now first we will discuss what is heat. You know, heat is a form of energy. Also you know law of conservation of energy. Energy neither be created nor be destroyed, but it can be converted from one form to another form, and total energy in a universe in the universe is a constant. That means energy neither be created nor be destroyed. It can be converted from one form to another form, and total energy in the universe is constant. Means total energy is constant. This is called as the principle of conservation of energy. Now you know, in case of electric heater, when electric energy will be given to the coil, then current will flow through the coil, and you know this current, electric current or electricity will be converted into equivalent form is called as heat. You know, in case of iron press, you know, when electric current will flow through the coil, then electric energy will be converted into heat. That means energy can be converted from one form to another form, and heat is also a form of energy. This is the definition of heat. It is a form of energy which represents the degree of hotness of a body. That means when you increase the temperature of body, or when you transfer heat energy from one region of body to another region, we will get sensation of only hotness, not a coldness. Heat is a form of energy which produces sensation of hotness That means when heat is flowing from one region of body to another region, we will get the sensation of hotness. That sensation of hotness or degree of hotness of a body is called as the heat. Once again, heat is defined as it is a form of energy which produces or which represents degree of hotness of body, or one can say which produces sensation of hotness of a body. You know, it is this heat is measured in joules or in calories or kilocalories. Therefore, its unit is joule or kilocalorie. That means heat is measured either in joule or kilocalorie. After that, we will see what is the temperature. Heat is a form of energy which measures the degree of hotness. Now, if you touch a piece of ice into the fridge, we will get the sensation of coldness. If you touch electric heater, if you touch to the fire, we will get the hotness of that is sensation of hotness. That means when heat energy will flow from one region of a body to another region, temperature of body changes, and due to change in temperature, we will get both the types of the feelings. That means ice produces the sensation of coldness and fire produces the sensation of hotness. Therefore, I can define temperature is defined as it is a measure of degree of hotness or coldness. That means temperature is a physical quantity which produces sensation of hotness or coldness. Both the sensations are we have to consider. If body is more hot, we will get sensation of hotness. If body is cold, if you touch the ice, we will get the sensation of coldness. We will get ice at a 0 degree Celsius. 0 degree Celsius is the corresponding temperature. If you consider the one can say boiled water, 100 degrees Celsius, at 100 degrees Celsius, one can say 100 degrees Celsius is called as the boiling point of water. We will get a sensation of hotness. Means due to temperature, if temperature of body is more, we will get sensation of hotness. If sensation of body temperature of a body is one can say lower, we will get the sensation of coldness. Means we are getting the sensation of either hotness or coldness, that is called as the temperature. Temperature is a physical quantity and heat is a form of energy. Heat is a form of energy which produces sensation of hotness, or it is a measure of degree of hotness, and temperature it is a measure of degree of hotness or coldness both. Then you know, heat energy will flow from one region of a body to another region. If you consider any solid body and if you heat the solid body at its one end or at its one region, then heat energy will flow from one region to another region. That means temperature shows the direction of flow of heat. When heat will flow from one region of a body to another region, temperature of body changes. That means I can say heat is the basic cause and temperature is its effect. Due to flow of heat from one region to another region, temperature of body changes. Therefore, I can say temperature is an effect and heat is a cause. Heat is a cause. Heat is a form of energy. And when heat will flow through any body, then temperature of body changes. Therefore, temperature is effect of flow of heat energy. And heat is measured in joule or kilocalorie or calorie. And temperature is measured in degree Celsius or Kelvin or Fahrenheit. These are the three temperature scales we have to discuss in detail in the one can say next articles. That means in first slide we have studied about the difference between heat and temperature. Heat is a form of energy which produces sensation of hotness, or it is a measure of degree of hotness. Temperature is a physical quantity which is measure of degree of hotness or coldness. Temperature, heat is a basic cause, temperature is its effect. When heat will flow from one region to another region, it produces change in temperature of a body. Therefore, heat is called as the cause and temperature is called as the effect. Then heat energy flows from higher temperature region of a body to lower temperature region, and temperature shows the direction of flow of heat. Heat is measured in joule or calorie or kilocalorie. Temperature is measured in degree Celsius, degree Kelvin or Fahrenheit. These are the basic ideas or the basic concepts about the heat and temperature. Now heat is a form of energy and it is measured in, basically it is measured in calorie. Now what is the calorie? See the definition. 1 calorie heat means what, or calorie means what, or 1 calorie means what? It is the amount of heat energy required to increase the temperature of 1 gram of a water by 1 degree Celsius. That means if you take a one beaker and in which if you keep 1 gram mass of a water and if you increase the temperature by 1 degree Celsius, suppose room temperature is 25 degrees Celsius, if you measure 1 gram mass, if you keep into the beaker and if you increase the temperature from 25 to 26 degrees Celsius, that means temperature is increased by 1 degree Celsius and mass of a water is 1 gram. Then whatever the heat energy we have supplied, that heat energy is called as the calorie. Calorie is 1 calorie can be defined as it is an amount of heat energy required to increase temperature of 1 gram of a water by 1 degree Celsius. In a parallel way, I can define kilocalorie also. Kilocalorie means if you take 1 kilogram of water in a beaker and if you increase the temperature of 1 kg of a water by 1 degree Celsius, how you can increase the temperature of 1 kilo of water by 1 degree Celsius? We have to provide heat energy, and whatever the amount of heat energy required to increase the temperature of 1 kg of a gas by 1 degree Celsius, then it is called as the kilocalorie. That means in calorie mass of a water is in gram, in kilocalorie mass of a water in kilogram. Therefore, calorie is amount of the amount of heat energy required to increase the temperature of 1 gram of a water by 1 degree Celsius. Kilocalorie or 1 kilocalorie is defined as it is the amount of heat energy required to increase the temperature of 1 kg of a gas by 1 kg of a water by 1 degree Celsius. Then 1 calorie, there is a relation between calorie and joule. 1 calorie is equal to 4.18 joule. In thermal engineering, for the students of mechanical engineering, we'll see, we are going to discuss all the properties or thermal properties of matter in detail in next year, but this one is the most important chapter for you. Thermal properties of matter, all these are the basic concept you should know before studying the thermal mechanical engineering. See the relation between calorie and joule. 1 calorie is equal to 4.18 joule. Keep this relation into the mind, how you can convert in calorie into joule. 1 calorie is equal to 4.18 joule. Now, after studying the definition of calorie and kilocalorie, we are going towards the temperature. Absolute zero means what? What is the concept of absolute temperature? Friends, you know, if you consider room temperature, suppose 30 degrees Celsius or 25 degrees Celsius, then if you decrease the temperature, then we'll proceed or we'll go towards a 0 degree Celsius. And you know 0 degree Celsius is nothing but 273 Kelvin. 273 Kelvin means 0 degree Celsius. 0 degree Celsius is called as the melting point of ice. That means 0 degree Celsius is equal to 273 Kelvin. If you go towards the negative degree Celsius, means minus 10 degrees Celsius, minus 20 degrees Celsius, theoretically, not practically, minus 30 degrees Celsius, minus 40, then Kelvin scale is also going towards the 0. 0 degrees Celsius is equal to 273 Kelvin. Means minus 273 degrees Celsius is equal to 0 Kelvin, I can say. Is it? Minus 273 degrees Celsius is equal to 0 Kelvin. Now, you know, if you increase the temperature of gas, then pressure and volume of the gas both are increasing. If you consider gas into the one container and if you increase the temperature, then expansion of gas takes place. Then volume is increasing. If the piston is movable, then the volume will be increasing, and if the piston is fixed, then pressure on the piston will be increasing. Therefore, if you increase the temperature of gas, pressure and volume both are increasing. If you decrease the temperature, then it is observed that at 0 Kelvin, that is minus 273 degrees Celsius, pressure and volume of gas both are becoming 0 theoretically. Practically this is not possible. Pressure and volume of a gas both are becoming 0 theoretically. Therefore, 0 Kelvin temperature is called as the absolute temperature. Therefore, I can define absolute temperature is the temperature of a gas at which pressure and volume of a gas becoming 0, both are becoming 0 theoretically. That means, you know, 0 degree Celsius is nothing but 273 Kelvin. That is minus 273 degrees Celsius is nothing but 0 Kelvin, and 0 Kelvin is called as a absolute temperature. Keep into the mind, if somebody asks you what is absolute temperature, 0 Kelvin is called as absolute temperature. 0 Kelvin is equal to minus 273 degrees Celsius. It is the temperature at which pressure and volume of a gas becomes zero theoretically. Pressure and volume of a gas become zero theoretically. That temperature is called as the absolute zero temperature. Now, after the definition of absolute zero, now we are going towards the main article, that is different temperature scales. You know, temperature is measured in Celsius scale, Fahrenheit scale, and Kelvin scale. Now, for each temperature scale system, lower limit of the temperature scale is fixed by taking melting point of ice. You know, melting point of ice is one can say in degree Celsius it is a 0 degree Celsius. Ice melts at a 0 degree Celsius. Therefore, 0 degree Celsius is called as the lower limit of Celsius scale. And higher limit is considered from boiling point of water. The water boils at the temperature is labeled as 100 degrees Celsius. Melting point of ice is called as the 0 degree Celsius lower temperature limit, and boiling point of water is represented by 100 degrees Celsius. 0 to 100 divisions are there. Therefore, this scale is divided into 100 equal parts. 0 to 1 first division, similarly 1 to 2, 2 to 3, in this way 100 equal parts are there. Melting point of ice is called as is labeled as the lower temperature limit 0 degree Celsius, and boiling point of water is labeled as one can say higher limit of the temperature scale, and which is 100 degrees Celsius. 0 to 100 equal parts are there in this temperature scale. Therefore, Celsius scale is nothing but one can, this scale is divided into 100 equal parts, and 0 to 100 degrees Celsius is called as the Celsius scale. Now, this scale Celsius temperature can be converted into its equivalent form is called as the Fahrenheit scale. Now, 0 degrees Celsius is nothing but 32 Fahrenheit. Therefore, melting point of ice is a 32 Fahrenheit. And 100 degrees Celsius is equal to 212 Fahrenheit. Therefore, 212 Fahrenheit is called as the boiling point of water. Now, see, 32 is a lower limit and 212 is higher limit. Higher limit minus lower limit. 212 minus 32, 180. That means this scale is divided into 180 equal parts. 180 divisions are there. 32 Fahrenheit is equal to 0 degrees Celsius, and start from 32. 100 degrees Celsius is nothing but 212 Fahrenheit. That means 212 minus 32. This scale is divided into 180 equal parts. That is called as the Fahrenheit scale. And third type of scale is called as Kelvin scale. In Kelvin scale, melting point of ice is 273 Kelvin. You can say 0 degree Celsius is equal to 273 degree Kelvin. You know, 0 degree Celsius is equal to 273 Kelvin. Therefore, melting point of ice is 273 and boiling point of water is 373. That is 100 degrees Celsius is nothing but 100 plus 273. That is 373 Kelvin. This scale is divided into 100 equal parts. That means, try to understand. Celsius scale is 0 to 100 degrees Celsius. 100 parts are there. Fahrenheit scale is starting from 32 and ends at 212 Fahrenheit. 180 equal parts are there. And in Kelvin scale, it is starting from 0 degrees Celsius means 273 Kelvin to 373 Kelvin. 100 equal parts are there. Now, how you can convert one temperature or one form of temperature into another form? Say, you know, temperature scale is divided into 100 parts, degree Celsius scale. T is for temperature, C is for Celsius. T is for temperature, C is for Celsius. Temperature in Celsius divided by 100 parts are there, equal to. Temperature in Fahrenheit is starting from 32. It is not starting from 0. Therefore, TF minus 32 divided by 180 parts are there. That means you can convert Celsius into Fahrenheit by using this equation. Celsius scale, Tc minus lower limit is 0. Therefore, you can write Tc as it is. Tc minus 100 parts are there, which is equal to. This scale is starting from 32. Therefore, in order to achieve 0, we have to subtract 32. Tf minus 32 divided by 180 parts are there, which is equal to. Kelvin scale is starting from 273. No, 273 Kelvin is called as the melting point of ice. Therefore, Tk minus 273, lower limit of the scale we have subtract from each temperature scale. Tc minus lower 0. Therefore, Tc by 100 equal to Fahrenheit scale is starting from 32. Therefore, Tf minus 32, lower temperature scale. Tf minus 32 divided by 180 parts, which is equal to Tk minus 273, lower temperature scale. That is melting point of ice. Tk minus 273 divided by 100 parts are there. Therefore, Tc by 100 equal to Tf minus 32 equal to Tk minus 273 divided by 100 is called as the relation between different temperature scales. If you know temperature in Celsius, you can calculate temperature into Fahrenheit. Now see, 1 degree Celsius means how much Fahrenheit? Put degree Celsius equal to 0. 0 divided by 100 means again 0. Then Tf minus 32 divided by 180 equal to 0. Therefore, Tf minus 32 equal to 0. 180 if you transfer towards the opposite side, it is again 0. Therefore, Tf minus 32 equal to 0. Therefore, Tf equal to 32. 0 degree Celsius is equal to 32 Fahrenheit. Then if you